One of the most important moments in history of AI is when the research team named DeepMind invent AlphaGo to beat world champion in 2016 in Go competition. Okay, so this marked the historical moment because I think it's the one of the first time that AI show its power to as intelligent as human, actually even more because it beat the world champion. And this AlphaGo algorithm is used the algorithm or model named reinforcement learning. That's why this reinforcement learning is a very important branch of AI and is really exciting to learn. Okay, let's get started. So in this course, tentatively, we're gonna have 5 or 6 lecture. Okay, so be careful. Is this course is every 2 weeks, not every week. Okay, in the morning we have lecture on 10 to 12 a.m. about the conceptual this lecture slide, and then in the afternoon we're gonna have lab session. Okay, around 2 to 4 p.m. So today we're gonna start with problem and framework of reinforcement learning with the very basics. Before we're gonna go into the algorithms in details in the incoming weeks. Okay, let me use the laser pointer. Okay, actually there is many great online lectures beside this lecture, of course. So you can see I put all the nice and great online course here. You can search all this name on the internet, and you can also study this course as a complementary to my course. Okay. Um, After all, I will use this book, the Reinforcement Learning by Richard Sutton and Andrew Battle, as the main reference. Actually, all of these guys also use this book as a main reference because this book is just like a Bible of reinforcement learning. Okay, so Professor Sutton and Battle, they are working in reinforcement learning for 30 or 40 years. They are grandmaster of reinforcement learning. So we will follow them just to make sure that we get everything right. And also, Hacking Face also have online reinforcement learning course in the template of blog. Yeah, it's also really nice and also easy to understand. You should take a look actually, and it provides like a lab session, and we're gonna take advantage of Hacking Face lab session. We're gonna practice that as our own lab session too in the afternoon for each week. Okay, for now, I think we should go into the detail of reinforcement learning. My name is Jung. Nice to meet you guys. So first of all, we're gonna start with what is reinforcement learning, why should we use it, and when should we use it. I mean, compared to supervised learning, when should we use reinforcement learning, or should we use supervised learning? And then after that, we're gonna go through the formal definitions of reinforcement learning, and then also the lab session, okay, in the afternoon. Reinforcement learning frameworks can be explained in this simple picture. Is learning from environment through trial and error. Okay, in the picture you can see the environment here. In our class, you can think of environment as a game. Okay, so it's really important a component of reinforcement learning. It's a game that you want to play and win. The other important component is the agent. Okay, so two important components, agent and environment. The agent is the program that you want to model and learn to play the game to win the game. Okay, so um, Okay, so the environment gonna send you the data to the agent, and after the agent receive the data from the environment, it gonna take some action. For example, the Mario, after it know the data, it gonna take the action, jump or moving forward or backward. Okay, environment gonna get the action and then gonna send data back, the new data to the agent. And the data actually consists of two things. So it's the state observation and the reward. Okay, so state observation is the current state of the game. Uh, in most cases, it can be think of like a game screen. For example, this one, the game screen can be thought of like a state observation. It's the current state of the game, right? So it makes sense. So in the current state of the game, you can see the Mario is here, the mushroom is here, and there are some monster. So the screen itself is the data that the environment sent to you along with the reward at the current reward of this state. You can see that the current state, Mario just standing still here. So there is no reward at all. So the reward is equal to 0. And actually in most game, most of the time, the reward is 0. When you play game for a while, you die after hitting a monster, or whether you win when you reach the flag here, maybe you get the big reward. Sometimes big negative reward. For example, if you die, maybe you get 10 minus 1000 point. Minus 10,000 points, sorry, you die. And then if you win, maybe you get 10,000 points. It plus 10,000 points. So after you play a game for a while, you're gonna get some useful reward. But most of the time, you get just 0 reward. Okay, so this the kind of characteristic of reinforcement learning, that most of the time you get 0 reward and still you have to learn from environment. This is different from supervised learning where you get useful rewards most of the time. And yeah, we're gonna have example to compare between these two frameworks on the next part. Okay, but for now, just know that this is the big picture of reinforcement learning, and the agent is what you want to program, and the environment here is important to understand that actually it's also another program. Okay, it's another program that somebody have to make it. In our course, we can assume that the environment, for example the game, is already exist, so you can focus to program the agent. The environment, we can, in our course, we can use the library called OpenAI Gym and Gymnasium that provide a lot of environment and games that we can train our agent on. But in real life, when you want to apply reinforcement into your own business, when you graduated from the university, maybe you want to have reinforcement learning to learn to trade a stock or to manage the inventory in your business. In that case, you have to program your environment by yourself, and you have to make it realistic enough such that when your agent play the game in your environment, it's just like a real life situation. And then when it wins, it's gonna be useful in real life. Okay, so if you make environment is a bad environment that is not look like the real environment, even if your agent can win the game, it's not gonna be useful in real life. But for now, anyway, we can just assume that the environment exists, and we're gonna focus on the agent part in our course. That is a big picture of reinforcement learning.